All right. So this example is the same Ferris wheel as in the previous example, except that now we want to write a function for the vertical distance from the first floor, okay, instead of the second floor. We want a function for the height above the first floor as an angle of theta, in terms of an angle of theta. Okay, so let's first of all just graph what that's going to look like. All right, so again, I'm just going to show one cycle, but now if you look our at our diagram here, we're starting out 20 feet, right? We're going to start out 20 feet above the first floor, right? Because this is our first floor. We're starting 20 feet above the first floor. We're getting as high as 20 plus 18, so 38 feet above the first floor. Then we come back down to 20 feet. And then down here at the bottom, we're only 2 feet above the first floor. So I need the range that I need to plot is between 38 and 2. Okay, so it's all above, it's all greater than 1. So I'm going to put my x-axis down here because I only need to plot values that are y values that are above 1. And I'm going to go between, let's say that this is 2, and let's say that, let me put this in here, let's say that this is 38. Okay, I'm going to have, my range is essentially going to be between 2 and 38. And then the midline, right, is going to be the height of the second floor above the first floor, right? Because that's where I'm starting out, and I'm going 18 feet up and 18 feet down from the midline. So I'm going to plot my midline through here, right, at 20 feet. Okay, 18 feet up, 18 feet down. And now let's just plot the points that where for each of those 4 points, right? At 0, pi over 2, pi, and 3 pi over 2. So at 0, we're starting out at 20 feet above the first floor. And so let's just mark those. We have pi over 2, we have pi, we have 3 pi over 2, and we have 2 pi. Okay, so that's one cycle. All right, so when we're up at the top of the Ferris wheel, right, that's 90 degree rotation, or pi over 2, and so we're at 38 feet above the first floor. Then we come back down at 180 degrees, or pi radians. We're back at 20 feet above the first floor. And then at 3 pi over 2, that's when we're down at the bottom of the cycle, and we're only 2 feet above the first floor. And then we come back to where we started. Okay, so this is what our function looks like. Okay, now it's still a sine wave, but now it's not only attenuated by the radius of the circle, it's also shifted. We've got a vertical shift up by 20 feet. Okay, so we have both a vertical stretch and a vertical translation. Okay, so the amplitude of our sinusoidal function here is 18 feet, and our midline is at y equals 20, right? If I'm calling this y as our height, and this is theta. All right, so how do we incorporate both a vertical stretch and a vertical shift into our function? We're going to multiply the function by 18, just like we did before, sine of theta, right? So that's what gives us our vertical stretch. And then we're going to add 20 feet to everything. So it shifts all the points up by 20 feet. Okay, so this is the amplitude, right? Which gives us a vertical stretch of the function, the basic sine function. And then this is our midline. right? And that's our vertical translation. We're shifting up by 20 feet. All right, so let's take a look at this box here. There's some generalizations here. So if we have a function in the form y equals a sine theta plus k, a is the amplitude. Now it's the absolute value of a, because sometimes we can flip it over. Amplitude is still a, but amplitude is always a positive value. So the amplitude is essentially a, or the absolute value of a, and the midline is that k value. The same thing happens with the cosine function. We can stretch it vertically by multiplying by a, right? That gives us our amplitude, and k is a vertical translation. Okay, so the midline is y equal k, and the amplitude is the absolute value of a. Okay, so that's a good thing to remember. That's all you really need to know for this section. I'm going to go through some more examples, but this is the key thing. This is the key thing that if you're going to, actually we're going to, in the next, in 9.5, we're going to extend this even further. But if you were going to have if you wanted to refer back to something, this is kind of the key idea from this section. All right, so I have several more examples to go through with you, and I'll meet you in the next video.